In the software landscape of 2026, we are witnessing a statistical anomaly that should terrify every engineering manager. Recent industry telemetry shows a staggering 98% increase in pull request volume, driven by LLM-integrated IDEs and autonomous coding agents. However, here is the failure state. Despite this explosion in code generation, organizational deployment frequency accord DORA metric has remained almost entirely flat. We are producing more artifacts than ever, yet our velocity in delivering value to the end user has stalled. The factory floor of software engineering is overflowing with parts, but the assembly line is jammed. This gap reveals that raw coding speed is no longer the primary lever for productivity. If your team is celebrating a high PR count while your release cycles remain sluggish, you aren't scaling, you're just creating a massive inventory of unvalidated code. By the end of this lecture, you will understand exactly why this gap exists and how to close it. But wait, where exactly did all that extra time go if we are writing code twice as fast? The hard truth for 2026 is that AI hasn't solved our productivity problem. It has simply moved the bottleneck. For decades, the constraint was writing the cognitive load of translating logic into syntax. Today, that cost is approaching zero. The new systemic bottleneck is integration, the process of reviewing, testing, and ensuring that AI-generated code doesn't introduce subtle regressions or architectural drift. We've shifted from a shortage of builders to a massive deficit of validators. When you increase the input speed at the start of a pipeline without expanding the capacity of the narrowest point, you create a systemic backup. In this environment, the ROI of AI is frequently negative because the time saved in writing is lost threefold in the resulting code review debt. We must stop asking how fast can we code and start asking how fast can we integrate. This shift in perspective is the only way to escape the illusion of progress. But how does this surge in speed actually feel for the humans stuck in the middle? Let's look at the physical sensation of this friction. I call this phenomenon acceleration whiplash. It is the organizational trauma that occurs when the sudden momentum of individual output hits the rigid wall of traditional review processes. Imagine a car accelerating from 0 to 100 in 2 seconds, only to slam into a dead-end street. In the developer workflow, this manifests as reviewer fatigue. Senior engineers who are already in high demand are suddenly bombarded with 5 times the usual number of PRs. Because the code was generated by AI, it often looks correct but lacks the deep context of the existing codebase, forcing reviewers to spend more time debugging than they would have if they wrote it themselves. This creates momentum friction where the team feels like they are moving fast, but the actual lead time for changes, the time from first commit to production, actually lengthens. This whiplash doesn't just slow down the product, it burns out your best talent. It is a collision between AI scale output and human scale oversight. What happens when this collision becomes the new normal? The answer lies in how we redefine our success criteria. The goal of this lecture is to give you the diagnostic tools to survive the 2026 landscape. We are going to move beyond vanity metrics like lines of code or PR count and focus on flow efficiency and mean time to integrate. You will learn how to identify the specific signals of whiplash in your own data before your team reaches a breaking point. We will establish a new framework for decision-making, when to leverage AI for speed, and when to intentionally slow down to preserve quality. By the end of this course, you'll be able to re-engineer your team's workflow to handle high-velocity input without the catastrophic whiplash effect. This is the difference between a team that is merely busy and a team that is truly productive. This transition starts with understanding the data. In the next chapter, we will dive deep into the specific DORA benchmarks of 2025 and 2026 to see exactly why this obsession with speed is breaking your quality. Are you ready to see the numbers behind the chaos? According to the latest 2026 DORA industry telemetry, we are witnessing a phenomenon I call the acceleration whiplash. While individual coding speed has reached record highs due to LLM-orchestrated agents, the organizational throughput is actually stalling. The most jarring statistic is the 4 to 41% increase in PR review wait times. We have optimized the writing phase so aggressively that the waiting phase has become the dominant state of the software lifecycle. In practical terms, developers are finishing tasks in minutes, only to have those tasks sit in a queue for days. This creates a massive decoupling between perceived individual productivity and actual system delivery. Is your team truly faster or just busier? Teaser: the answer lies in the sheer volume of code being shoved into these pipelines. Next, we look at the weight of these changes. Why is the review time exploding? It is a direct result of PR size bloat. In 2026, the average PR contains 51.3% more lines of code than just 2 years ago. When a human reviewer opens a PR with 100 lines of AI-generated boilerplate and logic, cognitive overload sets in immediately. Research shows that human review effectiveness drops by 80% once a PR exceeds 400 lines. We are essentially asking humans to perform high-stakes audit work on a fire hose of data. This leads to rubber stamping, where reviewers click approve simply because they lack the mental bandwidth to trace the logic of a machine-generated refactor. Question: if we can't effectively review the code, are we actually building or just accumulating? This imbalance creates what we now call review debt. Think of it like technical debt, but specifically located in the verification layer. As the AI code ratio increases, often exceeding 70% in high-velocity teams, the amount of unverified logic entering the main branch grows exponentially. We are creating a verification gap where the rate of code production is 10x faster than the rate of human comprehension. In many 2026 post-mortems, the root cause isn't a lack of tools, but a failure to validate AI suggestions that looked correct but failed in complex integration scenarios. Payoff. This debt isn't just a theoretical problem. It manifests as a literal crisis in software reliability. The data regarding software quality in 2026 is sobering. We've seen a 54% increase in reported bug rates per developer since the widespread adoption of autonomous coding agents. This isn't because the AI is bad at coding, it's because AI lacks architectural empathy. It doesn't know that a change in the billing module might trigger a race condition in the notification microservice because it only sees the local context of the prompt. We are seeing a surge in zombies code that works perfectly in isolation but creates monstrous side effects in production. Question: does more code always mean more value? The failure rates suggest otherwise. The most critical DORA metric, change failure rate CFR, has seen a massive 242.7% spike. This indicates that a significant portion of deployments are now causing outages or requiring immediate hotfixes. In the 2026 landscape, we call this the PR trap. Because code is cheap to write, teams are pushing more PRs, but each PR carries a higher uncertainty coefficient. We are seeing a process breakdown where the CI/CD pipeline passes because the AI wrote the tests, but the production environment fails because the AI couldn't predict real-world state mutations. Payoff. We've replaced coding time with debugging time, and the trade-off is becoming a net negative. To summarize this data-driven reality check, fast code is increasingly becoming expensive code. The productivity gains from AI are being cannibalized by the rising cost of maintenance and the risk of catastrophic failure. We are facing a technical debt 2.0 scenario where we own massive codebases that no single human fully understands. AI hallucinations have matured from simple syntax errors into complex architectural mismatches that are much harder to debug. If we continue on this path without changing how we review and validate code, 2026 will be remembered as the year software quality hit an all-time low. Now that we've seen the data, we must look at the specific mechanism of the clog, the review bottleneck. In the current 2026 landscape, we are witnessing a massive asymmetry in software engineering. While AI tools like GitHub Copilot or Claude 3.5 Sonnet can generate hundreds of lines of code or complex refactors in seconds, the human capacity to digest and verify that code remains unchanged. Senior engineers are now facing a review DDoS. An LM can produce a pull request containing a sophisticated implementation of React server components and nested caching logic in the time it takes to sip coffee. However, a human reviewer still requires 30 to 45 minutes of intense focus to ensure there are no subtle logic bombs, memory leaks, or security vulnerabilities. We have successfully automated the writing, but we have fundamentally failed to automate the understanding. This imbalance creates a massive inventory of unreviewed code that sits idle, effectively nullifying any gains made during the coding phase. But wait, the problem isn't just about time. It's at the mental toll this review DDoS takes on your most valuable team members. The hidden killer of productivity in 2026 isn't the code itself, it's the constant context switching. When every developer on a team uses AI to accelerate their output, the number of pull requests being opened triples. For a senior lead, this manifests as a relentless stream of Slack and GitHub notifications. Science tells us that it takes an average of 23 minutes to return to a state of deep work after a single interruption. If your lead developer is being pinged every 15 minutes to review an AI-assisted PR, they effectively never reach a state of flow. We are sacrificing our best architectural minds to the altar of review fatigue. They become the ultimate bottleneck, not because they are slow, but because the system is flooding them with high-volume, low-context changes. Is this the productivity we were promised? If we continue down this path, the review process itself becomes the primary constraint of the entire organization. Next, let's examine why this bottleneck is so resistant to traditional scaling. In engineering terms, we are dealing with a mismatch in elasticity. AI-driven code generation is highly elastic. You can scale it instantly by adding more seats or using more powerful models. In contrast, the human review process is highly inelastic. You cannot simply double a senior developer's reading speed or double the number of senior reviewers overnight. This creates a classic theory of constraints problem where the bottleneck has shifted from the code creation phase to the code integration phase. Many teams attempt to fix this by skipping reviews or using auto-approve bots, but this only leads to architectural erosion and technical debt that will haunt the project 6 months later. We are hitting a ceiling where more AI actually leads to less shipped value because the integration gateway is clogged. Is it possible that our favorite metrics, the ones we've used for years, are actually lying to us right now? Let's take a cold look at why your DORA dashboard might be giving you false confidence. DORA metrics have been the gold standard for a decade, but 2026 is the year they break. Consider lead time for change. Traditionally, a lower lead time meant an efficient pipeline. However, with AI, developers are pushing micro-PRs tiny, AI-suggested refactors or documentation tweaks to keep their metrics looking green. This results in metric dilution. You might see a 50% improvement in lead time, but the actual business value delivered remains stagnant or even decreases because the pipeline is full of noise. We are measuring the speed of the treadmill, not the distance traveled. When high-volume AI noise mixes with critical feature work, the lead time metric becomes a distorted average that hides the fact that your major features are actually taking longer to clear the review bottleneck. But there's another metric that's even more deceptive: deployment frequency. High deployment frequency is usually a sign of a healthy CI/CD culture, but in the era of acceleration whiplash, it can be a false positive for team health. We are seeing teams deploying 20 times a day, yet the underlying architecture is crumbling. Why? Because AI makes it incredibly easy to fix symptoms without addressing root causes. A developer sees a bug, AI suggests a quick patch, and it's deployed in minutes. Over time, these patch-on-patch deployments create a fragmented codebase that is impossible to reason about. The frequency is high, but the quality of change is low. We've moved from move fast and break things to move fast and patch things until they are unrecognizable. If your deployment frequency is high, but your change failure rate is also creeping up, or if you find yourself refactoring the same module every week, your metrics are masking a serious architectural failure. Next, we'll see why throughput is the most dangerous myth of all. We keep hearing about the 70% productivity gain from AI tools, but throughput is not value. If a factory produces 70% more cars, but they all have faulty brakes and get stuck at the final inspection gate, the factory hasn't actually gained anything. This is a throughput fallacy. In software, if your team is producing 70% more code, but your time to market for a major feature hasn't changed because of the review bottleneck, your productivity gain is exactly zero. In fact, it might be negative due to the increased maintenance burden of that extra code. In 2026, we must stop measuring how much stuff we build and start measuring the flow of value through the human constraints of our system. This requires a fundamental shift in how we define and track engineering success. This leads us to a critical realization. We need a new way to measure success, which is exactly what we will tackle in the 2026 Metric Overhaul in the next chapter. Traditional DORA metrics like lead time for changes are becoming obsolete in 2026 because AI agents can generate thousands of lines of code in seconds. When lead time drops to near zero, it no longer reflects team health, it reflects GPU speed. To counter this, we must adopt the review-to-code ratio. This metric measures the time senior developers spend auditing AI-generated logic versus the time the AI spent generating it. In a healthy 2026 engineering culture, a spike in code volume without a proportional increase in review depth is a red flag for technical debt. We are seeing a shift where the bottleneck isn't writing but validating. If your team's review-to-code ratio is plummeting, you aren't moving faster. You're just accumulating a massive shadow debt that will explode during the next major refactor. We need to stop rewarding lines of code and start measuring the cognitive load of the reviewer. But wait, looking at the volume of reviews alone is a trap. What about the quality of those specific changes? In the era of AI-driven development, PR iteration count is becoming the primary indicator of code quality. In 2026, if an AI agent submits a pull request and it passes through without a single human-requested change, it often suggests rubber stamping rather than perfection. We track the rework rate specifically for AI-generated blocks. When an AI agent handles a ticket, how many times does a human developer have to prompt it to fix a hallucination or a violation of internal architectural patterns? This rework rate is the true cost of AI. High rework rates indicate that the AI-human handoff is broken. Engineering managers should look for a sweet spot in iteration counts. Too few iterations mean the team has given up on quality. Too many mean the AI tool is more of a distraction than an accelerator. By benchmarking the iteration to merge time, we can finally distinguish between helpful agents and noise-generating bots. It's not just about the code itself, but actually understands it 6 months from now. The most dangerous byproduct of the 2026 AI boom is the knowledge dumper repositories grow by 500%. The team's collective understanding stays flat. We need to measure knowledge distribution using a modified AI-adjusted bus factor. If 90% of a critical module is written by a specific AI agent and reviewed by only one person who used a looks good to me shortcut, your bus factor is effectively zero. In a post-DORA world, we use mind maps to track ownership heat maps. We analyze who is actually answering questions in Slack or Jira regarding AI-generated modules. If the human knowledge anchor for a module is missing, that code is a liability, not an asset. Leading organizations are now implementing knowledge verification sprints where developers must explain AI-written logic to their peers to ensure the bus factor remains sustainable. Metrics for human reviewers are fine, but how do we grade the AI agents themselves before they even submit a PR? To survive the 2026 whiplash, teams are moving toward pre-review evals. Before a single human eye sees an AI PR, the code must pass through an agent orchestrationable framework. This isn't just about unit tests, it's about semantic validation. We use specialized LLM as a judge agents to check if the new code aligns with the existing design patterns and security standards of the organization. The metric here is eval pass rate. If an AI agent consistently fails the internal style and safety evals, its temperature or prompting strategy needs immediate tuning. By shifting these metrics left, we prevent the human review bottleneck from becoming a graveyard of low-quality code. We are measuring the correctness at the source, effectively turning our CI/CD pipelines into quality gatekeepers for AI agents. Even with high evil scores, how many of these corrected bugs are actually reaching production? In 2026, we measure auto-remediation rate against CI/CD infrastructure load. If an AI agent creates 100 PRs to fix 10 bugs, the noise-to-signal ratio is too high. We need to track how many AI-generated bugs are caught by automated tests versus those that leak into production. Interestingly, as AI agents become more aggressive, the load on our CI/CD systems is skyrocketing. We've seen cases where metric whiplash occurs because the CI pipeline is so congested with AI-generated test runs that human developers can't merge critical hotfixes. A key 2026 metric is inference cost per merged feature. This forces teams to consider if the computational cost and the alert fatigue from constant AI commits are actually providing ROI. We must balance the auto-fix capability with the reality of CI gridlock. We've seen the individual pieces, but how do we tie this back to the overall developer experience? To conclude our 2026 metric overhaul, we must shift our philosophy from measuring output to measuring integration flow. In the world of AI, output is cheap and infinite. Integration is expensive and human-constrained. The metrics we've discussed, review to code ratio, rework rate, and AI-adjusted bus factor all serve one purpose: to protect the flow of the engineering team from being drowned by AI-generated noise. The North Star for 2026 is verified deployment frequency. It's not about how often you deploy, but how often you deploy code that is fully understood by your human engineers. By focusing on these integration-centric metrics, you avoid the productivity trap and ensure that AI remains a tool for acceleration rather than a source of whiplash. This data-driven approach is your shield. In the next chapter, we will take these metrics and apply them to a concrete strategy for curing the whiplash and reclaiming your team's flow. The most visible symptom of AI productivity whiplash is the pull request explosion. With LMs like Claude 3.5 Sonnet or GitHub Copilot, generating 500 lines of code takes seconds, but reviewing them still takes hours. Industry data indicates a 51.3% increase in PR size when AI tools are used without constraints. To counter this, we must enforce a micro-PR strategy. This means establishing hard limits on change size, ideally under 200 lines, and forcing developers to break down AI-generated features into logical, reviewable units. This isn't just about convenience. It's about maintaining a lead time for changes that doesn't collapse under the weight of unreviewed code. We need to treat code generation as a debt-loading activity that requires immediate amortization. But simply making PRs smaller isn't enough if the review speed doesn't keep up. How do we automate the judgment itself? If we use AI to write code, we must use AI to review it. The current bottleneck is the human-only review model. By 2026, the standard architecture will involve automated guardrails where LLM agents perform the first pass of code review. These agents don't just check for linting, they look for semantic regressions and security vulnerabilities that traditional static analysis misses. We are moving toward a multi-layered review stack where the AI handles the syntactic and standard layers, leaving the human reviewer to focus on high-level architectural alignment. This balances the pipeline, ensuring that the speed of verification matches the speed of creation. Without this balance, your senior engineers will become human bottlenecks, drowning in AI-generated noise. Automated checks are great, but human interaction still causes the most delay. How do we restructure the human schedule to fit this high-velocity era? Traditional asynchronous code review where a PR sits in a queue until someone finds time is dying. In a high-throughput AI environment, review blocks or synchronous swarming are becoming essential. This involves dedicated hours where the entire team focuses solely on unblocking the PR queue. Instead of letting PRs rot for 48 hours, we aim for a 1-hour turnaround during these blocks. This minimizes context switching and aligns with the DORA metric for lead time. We have to stop treating code review as an interruption and start treating it as the primary manufacturing step. The goal is to move from a developer-centric flow to a throughput-centric system. Process changes are half the battle, but knowing when to pull the plug on AI generation is what separates senior leaders from hype chasers. Strategic adoption means knowing when AI is a liability. We need a decision matrix for AI usage. AI is excellent for low-context tasks, writing boilerplate, generating repetitive unit tests, or styling UI components. However, for high-context tasks like refactoring core business logic in a 10-year-old legacy monolith with zero tests, AI is a dangerous shortcut. In these scenarios, the AI will confidently hallucinate based on common patterns that don't apply to your specific technical debt. Teams must explicitly define OAI zones to prevent catastrophic regressions. If the cost of verification exceeds the time saved in generation, you must pause. Even with a perfect matrix, if you optimize for raw coding speed, your SRE team will eventually pay the price in production. In the AI era, stable throughput is more valuable than maximum coding speed. If your team is producing 10x the code but your change failure rate has doubled, you aren't more productive, you're just creating a bigger mess for the SREs to clean up. We must align AI usage with SRE reliability goals. This means introducing speed bumps into the development flow where stability is verified. We should reward engineers not for the number of tickets closed, but for the mean time to recovery and system health. High velocity without stability is just a faster way to crash. As we look toward 2026, the metrics will shift from how much code we write to how well that code integrates into the existing ecosystem. To survive the 2026 whiplash, your roadmap must prioritize integration health. We are moving from a builder culture, where the goal was to write as much as possible, to a curator culture. In this new world, the lead engineer's job is to manage the agentic workflow orchestrating AI agents that write, test, and deploy, while maintaining the human-centric vision of the product. The key is to build a culture that values the system over the individual. We must stop obsessing over individual productivity and start measuring the health of the entire pipeline. Now that we've diagnosed the whiplash and applied the cure, it's time to face the ultimate question. Will your role exist in this new reality, or are we just surviving until the next shift? Let's move to the final verdict. To survive the transition to 2026, you must first diagnose if your team is currently suffering from acceleration whiplash. Start by analyzing your DORA metrics, specifically the delta between your code commit volume and your change lead time. If your developers are pushing 5x more code, but your deployment frequency has stayed flat, you are officially in the whiplash zone. You need to verify if senior engineers are spending over 40% of their time on code reviews, which indicates a massive human-in-the-loop bottleneck. Check your change failure rate. A spike here suggests that AI-generated code is bypassing critical cognitive filters. Finally, assess documentation-to-code ratio. If the code is evolving faster than your internal knowledge base, your technical debt is compounding at an unmanageable rate. This diagnostic is not just a health check. It is a survival requirement for the coming year, but recognizing the problem is only half the battle. We need to define the new criteria for engineering excellence in 2026. By 2026, the fundamental nature of the bottleneck has shifted entirely from technical generation to social and cognitive validation. We have reached a point where machines can write code faster than any human can read or comprehend it. This means the elite teams of the future won't be defined by how many tokens they generate, but by how effectively they manage cognitive load. The key decision criteria for leaders must now center on reviewability over writability. We must move away from the obsession with raw lines of code and focus on system reliability and architectural integrity. If your team is still rewarding high PR counts without considering the review burden, you are optimizing for failure. The AI productivity trap is real, and it is built on the illusion that more code equals more value. In reality, the value lies in the human judgment that filters the noise. So, where do we go from here to ensure our teams don't just survive but thrive in this automated future? To bridge the gap between where we are now and the fully automated future, your next strategic move must be a shift toward agentic orchestration. We are moving past the era of the copilot that merely suggests code and into the era of agents that manage entire workflows. This requires a fundamental pivot toward review as code and the implementation of robust evaluation frameworks. Your roadmap for the next quarter should focus on automating the mundane parts of the review process and building LLM levels to verify code quality before a human even sees it. Stop trying to hire more developers to review more code. Instead, start building the infrastructure that allows one developer to oversee an entire swarm of AI agents. This is the only way to scale without breaking your team's flow. Our journey through the productivity trap ends here, but your journey into agentic workflows begins with our next series on AI orchestration and evals.